A ball of mass 50 gram is thrown vertically upwards and the velocity given upwards is 20 meter per second. We need to calculate the initial kinetic energy and the maximum height reached if air friction is neglected. Third part is the maximum height reached if 40% of its initial energy is lost against friction. So friction takes out some of the energy, only 40% is reduced, 60% is remaining. Okay, so let's see first part. We have to calculate the initial kinetic energy. So we can use the formula half mv square. Here we just have to put the values, just convert it into the kilograms and put the velocity value and you will get answer as 10 joules. So the initial kinetic energy of the ball when it just got released from our hand, right? Then upwards the kinetic energy was 10 joules. Okay, let's go next. So we are neglecting air friction. If we are neglecting it, so the kinetic energy which we have imparted in the ball, so that will be totally converted into the potential energy at the maximum height, and that is what they are asking, right? So we can calculate the height from there. Like this kinetic energy, 10 joule, will become 10 joule of potential energy here. And equating that, this is the kinetic energy we have, and this is mg delta h. So h we are taking change in height. If we are taking this as our releasing point, then we can assume that height is 0 here, so that we have to just calculate whatever the height it is, the maximum height. So mg delta h if you do, then you'll get the height h as 20 meter. So maximum height attained if air friction is ignored is a 20 meter. Let's do the last part now. In this case, they are told that there is a air friction which takes 40% of the initial kinetic energy. So we were having 10 joules of energy. So this much is lost. 4 joule will lost. So think about 40% as zero point 0.4. So 10 into 0.4, 4 joule is lost. So what is remaining? 6 joule is remaining, right? So remaining 6 joule of kinetic energy will take the ball to its maximum height. Again, we will use the same thing. Like if the kinetic energy is 6 joule here, it will go up and it will become the potential energy of 6 joule again, because entire 6 joule of energy will be converted into kinetic energy. And knowing the formula here, we can calculate the height because we know the potential energy formula, that is mg delta h. Again, we will apply this and this time we will get lesser value of 12 meter. So if we are considering the air friction, then the height maximum will be of 12 meter. So let's summarize this question, what this question was asking. It has asked some initial velocity kinetic energy we have given to the ball, and then initial kinetic energy they asked us to calculate. We calculate by this formula. Then they asked us to ignore the friction and ask what is the height it will reach. So we used whatever the kinetic energy below here, the same potential energy will be here if air friction is ignored because no energy is taken out. So we will use that logic like this. The potential energy is this, and this is the kinetic energy. It has to be equal to the kinetic energy here. So we calculated as 20 meter. Then the last is just a change that 40% is wasted. So only 60% is there. So this much energy, kinetic energy, it will also reach some potential energy, totally converted into that mg delta h. Again, we applied and got the height as 12 meters. Let's go to the next question. A ball of mass 20 gram falls from a height of 10 meter after striking the ground. It rebounds from the ground to a height of 8 meters. So it is coming like this from 10-meter height, coming like this, jumping it again, but only reaching 8-meter height. Maybe some because of some energy lost here, right? So they are asking the kinetic energy of the ball just before the striking the ground. We need to calculate that and the loss in kinetic energy of the ball on striking the ground. So we can calculate what is the potential energy initially we were having here. Okay, so that was mg delta h. We can calculate the same potential energy will be just here before striking. Just before striking, the total energy will be converted into kinetic energy. So we can calculate by this formula. mg delta h, and it was this 2 joules of energy before striking. This was the kinetic energy. Now it rebounds only to reach the height of 8 meter. Now why that happened? Because some energy is lost. But let's say it was having some kinetic energy reduced, but let's it go. So total kinetic energy will be converted into the potential energy in the second case at the height of 8 meter, P2, right? This is, let's say, P1. So why it is only raising it? Because we are giving less kinetic energy to it. So whatever the kinetic energy going upwards after the strike, that has to be equal to this. And see this, whatever the potential energy, kinetic energy we were having here, KE1 before striking, that was coming from this, the potential energy before. So if you want to find the difference, loss of kinetic energy, that's what I'm asking. Loss in kinetic energy of the ball striking the ground, it will be the same as difference between the potential energy which it was and which is now. So that we can calculate. Just we need to calculate the potential energy at 8 meter. So the mg10 minus mg8 meter, mg2, and we can calculate. So the potential energy difference is of 0.4 joules. So here it is 0.4 joules. That is the loss of potential energy. So what is the remaining energy? If you see 1.6, right? Because the total was 2 joules here. Okay, so let's summarize this question. What was happening in this question? In this question, the ball was dropped, and when it was rebounding, it was not coming at the same height. So they were asking what is the initial kinetic energy when it is about to strike the ground. So that will be the energy which was it was having before. The potential energy got converted into kinetic energy. Now it will lose some energy here, some dissipation, and then it will raise up. But going up, it will entirely convert it again, and the distance is given 8 meter. So what we used the simple, the intuition that the difference in kinetic energy will be equal to difference in potential energy because they are wholly getting converted. So that's why we used this kind of approach. Let's see the third question. A simple pendulum, when oscillating, rises to a maximum vertical height of 5 centimeter from its rest position, and it reaches to one side of its extreme position. If mass of bob of simple pendulum is given this much and g we have to take 10, we have to calculate the total energy of the simple pendulum at any instant. Total energy means they are asking about the mechanical energy, which is potential energy plus kinetic energy. So if you see at the extreme, we will only have potential energy. So it will be having speed like this, but when it reaches stop, it will slow down, slow down, slow down, and the kinetic energy will be zero because the entire kinetic energy has been converted now into the potential energy. So here, whatever the potential energy we are having, that is equal to the mechanical energy, right? So if we are able to calculate the potential energy here, it means we are able to calculate the mechanical energy also. Similar the case if, like, for example, we know the speed of this, like the kinetic energy at this point, rest position. So this will come down, and at this point, the potential energy will be completed converted into the kinetic energy. At this moment, this kinetic energy, because potential energy is zero here, will be equal to mechanical energy. Okay, what about in between? In between, there will be part potential energy, part kinetic energy. So anyway, they are asking total energy of simple pendulum. So that will be just the potential energy at the extreme. We can just read the theory here. The mechanical energy of the pendulum remains constant at any instant. Mechanical energy is given as this. At extreme position, there will be only potential energy as the bob momentarily comes to rest. K is 0 because V is 0. Mechanical energy will be this, only potential energy. Potential energy, we have a formula, mg delta h, height is given, mass is given, g also is asked to take 10. So we'll calculate as 0.25 joules. As mechanical energy remains constant because only gravity is acting on it, and that is a conservative force. So in the case of when only conservative forces are acting, the mechanical energy remains constant. So at any instant, it remains same. Let's do the next part. What is asked in the second part? The velocity of the bob at its resting position. Okay, so now what we have done, this was swinging like this. Let me pull it up. Yeah, it was swinging like this, and now it is coming back. So how much kinetic energy it will have? The entire potential energy which was at the extreme will not converted into the kinetic energy here at the resting position. So we have already calculated this. So we know at the resting position what will be the kinetic energy, right? So if we do like this, we can just calculate mg delta h. We have already calculated it, and you can apply it again by just equating mgh by half mv square. You will get square root of 2gh, and if you solve this, you will get plus minus 1 meter per second, because square root of 1 is plus minus meter per second. Again, which value we should report? We should report the positive value as positive 1 meter per second. But why it is giving us two values? Because it does not matter. The math will not think about which way it is swinging. The kinetic energy will be same going this way. And if it comes back like this, if you have taken this as positive 1 meter per second, it will give the same kinetic energy. If it comes like this as we were taking, there is a negative side. If you have imagined that, then we will say the velocity is minus 1 meter per second. That also will give us the true answer, correct answer, because the kinetic energy will be the same because it squares. So negative will not matter. But anyway, in our textbook, we'll report it as positive 1 meter per second.